It's morning, about 40,000 years ago, somewhere among dry grass and warm rocks. You're barefoot, because everyone is barefoot, and you're walking slowly through the tall vegetation, looking for roots or following the trail of a small animal. The ground is warm, the wind rustles the grass in waves, and for a second, you step on something that shouldn't be there. It's not a rock, it's not a twig. It's soft at first, then it isn't soft anymore, and before you can process anything, a sharp, precise pain shoots up from your ankle. 2 exact points, almost surgical, as if someone had pricked you with hot needles. You never saw what bit you. It's already vanished back into the grass, a gray streak you barely noticed. And now you're alone, your heart racing, not knowing if you're about to die in the next 20 minutes or if, an hour from now, you'll be laughing about this around the fire. This scene has played out, without exaggeration, countless times throughout the history of our species, long before there was any concept of poison, the nervous system, or blood clotting. And the most honest answer to the question, how did prehistoric humans survive this, isn't as heroic as we'd like it to be. There wasn't a brilliant healer who knew exactly what to do. There wasn't a first aid kit hidden behind a tree. The truth is stranger than that. Most of the time, the human body was already, by design, prepared for this exact threat, long before any human decided to do anything about it. And here's the first thing almost no one knows. Most snake bites, even from extremely dangerous species, don't inject any venom at all. This is called a dry bite, and it's not a rare accident. It's a deliberate strategy on the part of the animal. Producing venom costs real biological energy. The glands that manufacture these complex toxins consume precious metabolic resources, and for the snake, venom is essentially expensive ammunition saved for hunting food, not for defending itself against a creature too large to be swallowed. When a snake bites a human, in most cases it is merely sending a warning, a "leave me alone," and consciously, or at least instinctively, holds back the release of the toxin. Estimates for species studied today show that between 20 and 50% of snake bites in humans are dry bites, depending on the species and the situation. This means that, without doing absolutely anything, no herbs, no rituals, no special luck, a huge number of people throughout history simply got a scare and went on with their lives. But this still leaves a huge number of cases in which the venom actually enters the bloodstream. And that's where the second part of this story comes into play, a part that dates back to long before humans existed, and that has to do with why you probably get an automatic shiver when you see something long wriggling on your bedroom floor, even though you know perfectly well it's just a charger cord. There is a serious theory in neuroscience and anthropology called the snake detection theory, which argues that a considerable part of the visual system of primates, including our own, evolved specifically under pressure from crawling predators. It's no exaggeration to say that snakes helped shape the primate brain. Studies with monkeys show that there are specific neurons in the amygdala, the brain structure linked to fear and the alarm response, that fire faster and more intensely in response to the shape and movement of a snake than to any other visual stimulus tested, including the faces of other predators. Human infants, just a few months old and with no prior experience with real snakes, already show distinct visual attention when viewing images of snakes compared to other curved and sinuous shapes. This is not learned. It is inherited. In other words, long before any prehistoric human developed a conscious survival strategy, evolution had already installed an early warning system, honed over millions of years of coexistence between primates and snakes. And this alarm made a real difference. Spotting the snake a second earlier, noticing the movement out of the corner of one's eye, feeling that irrational chill even before consciously processing what one was seeing. That was exactly the kind of advantage that distinguished those who backed away in time from those who stepped right on the creature. Populations with this more finely tuned reflex tended to survive longer and leave more descendants, which reinforced, generation after generation, this specific fear response. It is no coincidence that the fear of snakes ranks among the most common and universal fears across cultures completely isolated from one another, from the Arctic to the Amazon. It is a fear too ancient to have been invented by any particular culture. It is worth noting that this alarm was not distributed equally across the planet, and this matters more than it seems at first glance. Regions where venomous snakes were historically more common, such as parts of Africa, Asia, and the Americas, appear to have exerted a more intense and more constant selective pressure on ancient human populations than regions with few dangerous species. Some researchers hypothesize that this helps explain certain subtle, and still debated, differences in how different human populations react visually and emotionally to stimuli resembling snakes. It is not a difference in courage or culture. It is the expected result of thousands of generations living in more or less direct contact with the same specific type of silent threat. Where the pressure was greater, the reflex tended to become sharper. Where it was lower, the body simply didn't need to invest as much in that specific alarm system. But reflexes and luck don't solve everything. When venom actually enters the body, what happens next is a matter of raw biological physics, and here the story takes a darker turn. Snake venoms are not a single substance. They are complex cocktails that vary enormously among species. Some are predominantly neurotoxic, attacking the nervous system and potentially paralyzing the muscles responsible for breathing. Others are hemotoxic, destroying tissues and interfering with blood clotting, causing internal bleeding that can take hours or days to kill. And what determines whether a person survives a truly venomous bite does not depend on rituals or beliefs. It depends essentially on three things: the amount of venom injected, the victim's body weight, and the location of the bite in relation to major blood vessels. A robust adult bitten in the thigh muscle, far from a major vein, has a much greater natural chance of survival than a small child bitten near the neck. This means that in prehistory, survival after a truly venomous bite was, for the most part, a biological lottery, decided even before any human decision came into play. And this is exactly where the popular version of the story begins to fall apart, because almost everything that popular culture associates with ancestral first aid for snake bites is, at best, useless, and at worst, actively dangerous. Sucking out the venom with your mouth, that classic adventure movie scene, removes practically no venom from a deep wound, because the venom spreads through the tissue too quickly to be sucked back out, and it also puts the person doing the sucking at risk if they have any cuts in their mouth. Cutting the skin in a cross over the bite, another classic, only increases tissue damage and the risk of infection without removing practically anything. Tight tourniquets, which completely cut off circulation to a limb, often do more harm than good, concentrating the venom in a single area and increasing the risk of the person losing the entire limb to necrosis when circulation is restored. Much of what we consider ancestral wisdom about snake bites is, in fact, folklore that has survived because most people who did these things would have survived anyway, either because the bite was dry or because the dose was small. It's tempting to imagine that a species as intelligent as ours would have discovered, sooner or later, some decisive trick to turn the tide against the venom. But intelligence is no substitute for biochemistry, and no amount of collective ingenuity can neutralize a toxin that acts within seconds inside the bloodstream itself, without any instrument to observe what's happening inside. This does not mean that nothing ancient humans did had any value. There were, in fact, some practices that we now know worked, even if for reasons they did not fully understand. Keeping the victim as still as possible, avoiding running or moving about, does indeed slow the absorption of the venom into the bloodstream, because muscle movement accelerates lymphatic circulation, which is one of the main routes of dissemination for certain types of toxins. Hunter-gatherer groups in different parts of the world, independently of one another, arrived at this same practical conclusion, even without any knowledge of the lymphatic system. The person who had been bitten was laid down, kept calm, and carried, rather than allowed, to walk. Whether by chance or through empirical observation accumulated over generations, this was one of the few interventions that actually helped. There were also plants used topically or ingested that, in some cases, had real, albeit modest, properties for reducing local inflammation or pain, even without neutralizing the venom itself. The problem is that these plants varied from region to region, knowledge was passed down orally and in a fragmented manner, and there was no way to systematically test what actually worked versus what only seemed to work, because the person would have survived anyway. For every genuinely useful herb, there were likely dozens of others that were pure ritual, reinforced generation after generation by the same bias that allows any superstition to survive. When it works, you remember it and tell everyone. When it doesn't work, the person simply isn't there anymore to contradict the story. There is also a bolder idea, which sometimes comes up in connection with this topic, that some ancient populations may have deliberately exposed themselves to small amounts of poison in an attempt to develop some kind of resistance. This notion even has a name: Mithridatism, derived from an ancient king who supposedly ingested small doses of poison regularly for fear of being poisoned by enemies. The problem is that this works only to a very limited extent, and almost exclusively for toxins ingested orally in controlled doses, not for poisons injected directly into the bloodstream via a bite. The human body can, in theory, develop some partial immune response to certain proteins present in specific venoms after repeated and carefully measured exposures, something that is now being seriously studied in laboratories under extremely controlled conditions. But doing this without any sense of dosage, without understanding what the body was being exposed to, was a terribly risky gamble, far more likely to kill than to protect. There is no solid record that any prehistoric society consistently mastered this technique. What does exist is a vast amount of trial and error lost to history, where error, more often than not, simply meant there was no one left to report the outcome. And it is precisely this point that reveals something deeper about the relationship between humans and snakes throughout history, something that goes beyond physical survival. Because, if you stop to think about it, the snake is one of the few animals that appears almost universally as a central figure in the mythologies of cultures that never had contact with one another. Mesoamerican, Egyptian, Hindu, and Greek cultures, as well as the indigenous cultures of Australia, have all, independently, placed snakes at the center of their cosmologies, sometimes as a symbol of death and poison, sometimes as a symbol of healing and renewal. The very symbol of modern medicine, that staff with a coiled snake, comes from Greek mythology, associated with Asclepius, the god of healing, precisely because the ancient Greeks observed that the snake shed its skin periodically and saw in this a metaphor for rebirth, for surviving the very poison of existence and starting anew. It is a remarkable irony. The very animal that killed with more silent efficiency than almost any other terrestrial predator became, in virtually all ancient civilizations, also a symbol of forbidden knowledge, healing, and transformative power. It is no exaggeration to say that few animals have occupied such a contradictory and profound psychological space in the history of human consciousness as the snake. This may explain why healers and shamans in virtually every documented pre-agricultural culture assumed an almost sacred role, specifically in relation to snake bites, far beyond the role they played for other types of injuries. It was not merely a practical matter of treatment. It was a matter of mediating an encounter with something that the culture already understood, even without a scientific vocabulary, as lying on the frontier between ordinary life and something greater, older, more closely tied to the realm of the sacred and the dangerous at the same time. A snakebite was not treated as a simple accident. In many cultures, it was treated almost as an encounter with a force that demanded a ritual response, not just a medical one. And perhaps this is not as irrational as it seems at first glance. Because, even without understanding venom in biochemical terms, these cultures were tapping into something real. A snakebite was, statistically speaking, one of the most unpredictable and terrifying causes of death in prehistoric human experience, because it combined two things rarely found together: the total invisibility of the attack and an outcome that could be either extremely rapid or extremely slow, depending on factors completely beyond the control of the person who was bitten. There was no visible enemy to fight, no right decision to make. There was only waiting to see which side of the biological outcome you had landed on. This is a very specific kind of psychological terror, and it's reasonable to think that much of the symbolic weight we place on snakes, even today, stems precisely from this ancestral inability to control the outcome. The real turning point in the history of snakebite survival did not occur until extremely late, relative to the timescale of our species. It was not until the late 19th century, in 1895, that the French physician Albert Calmet developed the first effective antivenom by injecting controlled doses of venom into horses and then extracting the antibodies produced by their immune systems. Before that, throughout virtually the entire existence of the human species, the line between surviving and not surviving a truly venomous bite depended almost entirely on biological factors that no one could control, rather than on any conscious human intervention. It's hard to accept, but it's the most honest truth science has to offer on the subject. For tens of thousands of years, the real answer to how did humans survive venomous snake bites was, for the most part, they didn't always survive. And when they did, it was often not because of what they did, but in spite of it. There is something genuinely sobering about this realization, and it's worth pausing to reflect on it for a moment rather than simply moving on to the next curiosity. Because this changes the way we view all the cultural baggage we carry today regarding snakes, fear, and invisible danger. That irrational shiver you feel when you see something moving in the tall grass isn't just a whim. It isn't a senseless modern phobia. It's a functional echo of a time when that reaction, tenths of a second faster than conscious thought, was literally the difference between continuing to exist and becoming yet another silent statistic lost to history. Every generation that survived long enough to leave descendants carried, even without knowing it, a little more of that sharp alarm. You didn't choose to be afraid of snakes. Your ancestors chose for you, bite after bite, generation after generation, over a span of time so long that it's almost impossible to truly visualize. So when someone asks how prehistoric humans survived venomous snake bites, The honest answer isn't about bravery, nor about lost ancestral knowledge, nor about secret remedies hidden in some forgotten tradition. It's about a body that's already factory set, with reflexes shaped by millions of years of coexistence with slithering predators. It's about the statistical luck that most bites never actually injected any venom. It's about a few practical measures, such as staying calm and still, discovered through trial and error, and passed down more by collective instinct than by real understanding. And it's about an enormous amount of pure, silent terror, later transformed into myth, into symbol, into ritual, because it was the only way to make sense of a danger that could neither be seen coming nor controlled once it struck. The snake didn't need venom to leave its most lasting mark on us. It was already inside our brains long before it was anywhere near our feet.